अस्सलामुअलैकुम डियर स्टूडेंट्स। लास्ट वीडियो लेक्चर में हमने डिस्कस किया व्हाट आर aryl halides, number second classification of aryl halides, number third that's nomenclature of aryl halides, and the fourth one was the methods of preparation of aryl halides. आज का टॉपिक जो है that is regarding the polarity, that's regarding the nature of the CX bond. टॉपिक जो है nature of the C-X bond. यहाँ पर है benzene ring and we have attached the halogen atom to it. Then this carbon atom and this halogen atom, what is the nature of this bond, यही आज हमें डिस्कस करना है. So we have, इससे पहले हमने डिस्कस किया व्हाट आर अल्काइल हैलाइड्स. वहां पर भी हमने डिस्कस किया द नेचर ऑफ द CX बॉन्ड, उसमें भी है CX बॉन्ड. यहाँ पर एराइल हैलाइड्स में भी है CX बॉन्ड. अब देखो यहाँ पर जो है एराइल अल्काइल हैलाइड, कार्बन and halogen atom. Halogens are more electronegative, they attract the electrons more towards itself, due to which it attains the partial negative charge, and carbon it attains the partial positive charge, and hence the bond it gets easily cleaved and it results and then it undergoes the reactions, various types of reactions. One of the important reactions shown by the alkyl halides, that's nuclear substituted these nucleophilic substitution reactions are shown by the alkyl halides. क्योंकि यहाँ पर जो बॉन्ड है वो ब्रेक हो जाता है. हेलोजन जो है दैट्स मोर इलेक्ट्रोनेगेटिव एज कम्पेयर टू द कार्बन, सो न्यूक्लियोफाइल आता है, अटैक करता है, देन हेलोजन इज रिमूव्ड एंड इट रिजल्ट्स द कंपाउंड दैट इज CnU. लेकिन यहाँ पर जो है कार्बन और हेलोजन एटम के दरमियान बॉन्ड ये ज़्यादा रिएक्टिव नहीं होता है एज कम्पेयर टू दैट ऑफ द अल्काइल हैलाइड्स. नाउ व्हाट इज द रीजन व्हाई द CX bond of the aryl halides is less reactive than the CX bond of the alkyl halides? There are the various reasons behind it. We are here discussing the three important reasons why the CX bond of the aryl halides is less reactive than that of the CX bond of the alkyl halides. Number first factor which explains the low reactivity of aryl halides, the CX bond of aryl halides, that is the conjugation effect. Now what is this conjugation effect? यहाँ पर हमारे पास है बेंजीन and we have the halogen attached to it, and halogens पर क्या होता है, three lone pair of electrons are here, and this lone pair of electrons they undergo resonance with the aromatic ring. यहाँ आएगा that's lone pair and it result is this lone pair it shows resonance with the aromatic ring like this. Here we have negative double bond, and here we have the X and positive. And in the another resonating structure we have here, this gets shifted to this para position. We have negative double bond, X positive. And in another resonating structure we have another resonating structure. Yes, in all these resonating structures you see there is a double bond character between the carbon and the halogen atom, double bond. So it is very difficult to break this double bond as compared to the CX bond where we have only a single bond between the carbon and the halogen atom. So in case of aryl halides we have the conjugation effect. Now what is this conjugation effect? It is simply the resonance of the lone pair of electrons of the halogen atom with the benzene or the aromatic ring, due to which a double bond character is introduced in the aryl halide in the CX bond, and hence it is very difficult to break this bond. So this is the first factor which explains us the low reactivity. क्यों? क्योंकि ये double bond easily break नहीं होता है, and it explains us the low reactivity of the aryl halides. So this is the first factor, that's the conjugation effect. Number second, hybridization of the carbon atom of the aryl halide. Number second is that is hybridization. Number second, hybridization. Hybridization of the carbon of the aryl halide. Hybridization of the carbon of the aryl halide. कार्बन एटम जो होता है aryl halides में वो है sp2 hybridized, while as the carbon atom of the this alkyl halides, that is sp3 hybridized. So we have C dash X in case of aryl halides. Aryl halides ये क्या है sp2 hybridized, and here we have the C dash X bond of this alkyl halides. It is sp3 hybridized. So this sp2 hybridized carbon of the aryl halides, it does not supply the electrons to halogen atom easily as compared to that of the carbon atom of the alkyl halides, which supply the electrons to the halogen atom easily, due to which the bond here it becomes more polar as compared to this. There is less electronegativity difference between the sp2 hybridized carbon of the aryl halide and the halogen atom, due to which the bond it becomes less polar, and hence it does not undergo cleavage, and hence they are less reactive as compared to the alkyl halides, where there is the bond it becomes polar and it is easily cleaved, and then it shows the various types of the reaction. This is the second factor which explains us the low reactivity of the aryl halides. Number third, that is polarity. Polarity of the C-X bond. जो मैंने आपको अभी बोला कि that C-X bond of aryl halides is less polar as compared to that of the C-X bond of the alkyl halides, which also explains us the low reactivity of the aryl halides. Less polar क्यों? क्योंकि यहाँ पर है sp2 hybridized and it is there is less electronegativity difference, and this carbon it does not supply the electrons more towards the halogen atom, and hence it shows the less reactivity of the bond, and the bond it becomes the less polar. These are the three factors which explain us the low reactivity of the aryl halides. Aryl halides जो होते हैं they are less reactive as compared to that of the alkyl halides. अब क्यों है less reactive? Because of the following three factors. Number first, that is the conjugation effect, which explain as the low reactivity of the aryl halides. Number second, that is hybridization of the carbon of the aryl halide, which is sp2 hybridized, while in case of the alkyl it is sp3 hybridized. And number third point जो है which explains as the low reactivity, that's the polarity of the CX bond. CX bond जो होता है aryl halides में वो less polar होता है as compared to that of the CX bond of the alkyl halides. These are due to which जब यहाँ पर ये बॉन्ड क्लीव नहीं होता है, ड्यू टू विच दे शो द रिएक्शंस ऑफ दिस न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन बट अंडर ड्रास्टिक कंडीशंस, व्हाइल एज अल्काइल हैलाइड्स जो है दे इजीली शो द न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शंस बिकॉज दिस बॉन्ड इट इज वेरी reactive as compared to this. It is here there is that electronegativity difference, this electron attracts the electrons more towards itself, and hence the bond it gets easily cleaved. So aryl halides जो है हमारे पास they are less reactive as compared to that of the alkyl halides, and they show the nucleophilic substitution reactions but under drastic conditions. Nucleophilic chemical reactions of aryl halides. Chemical reactions of halide. Aryl halides show the nucleophilic substitution reaction but under drastic conditions. They show nucleophilic substitution reactions under drastic conditions. They show nucleophilic substitution reactions under drastic conditions. For example, reaction with sodium hydroxide NaOH. अगर हम क्लोरोबेंजीन लेंगे, ऐड करेंगे इसको सोडियम हाइड्रोक्साइड, it results the formation of sodium phenoxide ONA, and which upon acid minus HCl, which upon acidification HCl ऐड करेंगे, that results the formation of the phenols. यहाँ पर डायरेक्टली बॉन्ड क्लीवेज नहीं होता है, that is the C-X, and here we have the OH group and it comes here. No, it is not there. First the sodium phenoxide is formed and then upon acidification it results the formation of the phenol, and this reaction is called as the Dawes method for the preparation of the phenols. So this is the first nucleophilic substitution reaction shown by the aryl halides under drastic conditions. Number second, reaction with ammonia or sodamide. Reaction with ammonia NH3. अगर हम बेंजीन क्लोरोबेंजीन लेंगे, ऐड करेंगे इसको अमोनिया NH3 in presence of cuprous oxide, it results the formation of aniline. This is another reaction, nucleophilic substitution reaction shown by the aryl halides under drastic conditions. So these are the two important nucleophilic substitution reactions shown by the aryl halides under drastic conditions. Now mechanism of these reactions, nucleophilic substitution reactions, they follow the two types of mechanism. One is called bimolecular nucleophilic substitution mechanism, and number second is called as the elimination or benzyne mechanism of nucleophilic substitution reactions. Mechanism of nucleophilic substitution reactions of aryl halides. नंबर फर्स्ट मैकेनिज्म जो ये फॉलो करते हैं, दैट इज बायोमोलिकुलर डिस्प्लेसमेंट मैकेनिज्म. इस मैकेनिज्म को हम इसका दूसरा नाम है एडिशन एलिमिनेशन मैकेनिज्म. Elimination mechanism. Addition elimination mechanism. अब एडिशन एलिमिनेशन मैकेनिज्म में क्या होता है कि न्यूक्लियोफाइल आता है, बिकॉज दिस इज द मैकेनिज्म ऑफ न्यूक्लियोफिलिक सबस्टिट्यूशन रिएक्शंस ऑफ द aryl halides. मैकेनिज्म में क्या है कि this mechanism is called bimolecular displacement mechanism, or that's called the addition elimination mechanism. फर्स्ट स्टेप में क्या होता है कि न्यूक्लियोफाइल आता है, वो ऐड हो जाता है, and in the second step the aryl halide it gets displaced. So it is first addition and then there is the elimination. Addition किसका हो जाता है? न्यूक्लियोफाइल का. फिर eliminate कौन होता है? halide ion eliminate होता है. तो सो यहाँ पर क्या है? बेंजीन रिंग है, अटैच्ड इसको है, दैट इज द Cl. सपोज न्यूक्लियोफाइल आ गया, न्यूक्लियोफाइल it gets attached to it. Here we it results the formation of a carbanion Cl and Nu. This compound, this intermediate, it is resonance stabilized. It is carbanion, this is resonance stabilized. Negative. Here we have the Cl and Nu. Then we have another resonating structure because this is resonance stabilized. Cl and Nu. Cl बाहर निकलेगा, ये यहाँ आएगा, and it results the formation of our compound. That is the addition, elimination mechanism, nucleophilic substitution. This is the nucleophilic substitution reaction where mechanism where we have in the first step we have the addition of the nucleophile. Add हो जाता है nucleophile and it results the formation of the carbanion, which then eliminates the chlorine halide and it results the formation of the substituted product. This is the first mechanism which is called as the addition elimination mechanism. Now the second mechanism that's called as the benzene mechanism. Number second mechanism जो है that's called benzene mechanism or it's called elimination addition mechanism. इसमें क्या होता है कि पहले eliminate हो जाता है halogen atom from the aryl halide. Then in the second step the nucleophile gets added and it results the formation of the substituted product. कैसे? Suppose we have again here chlorobenzene and if we add solamide to it, NH2 in presence of liquid ammonia, it results the formation of aniline. अब हमें दिखाना है कि कैसे बनेगा the mechanism of this reaction. Mechanism of this reaction, यहाँ पर आप देखिए कैसे होता है. Cl and here we have the hydrogen atom attached to it and here we have the NH2, that's the amino group from the solamide. It breaks and gives the amino group which abstracts the proton, acidic proton from this chlorobenzene like this. And here we have the elimination of the halogen atom minus Cl and it results the formation of the benzene. This is called as benzene. This is an intermediate and then this intermediate it gets attached with the nucleophile gets added to it. In the second step the nucleophile gets added to it here. NH2 and here we have the negative and this negative it will abstract the proton from the ammonia. It will abstract the proton from the ammonia and it results the formation of the product. So आपने इस mechanism में देखा पहले eliminate हो गया halogen atom and in the second step results the formation of an intermediate which is called as the benzene and in the second step we have the addition of this nucleophile results the formation of the substituted product. But this is the second mechanism, nucleophilic mechanism shown by the aryl halides. The nucleophilic substitution reactions of the aryl halides, they show the nucleophilic substitution reaction but under drastic conditions. And then we have the following two reactions, nucleophilic substitution reactions of aryl halides. Then we have the mechanism of those nucleophilic substitution reactions of aryl halides. This is all about today's topic. So आज के टॉपिक में हमने आज डिस्कस किया व्हाट इज द नेचर ऑफ द CX bond. what are the various factors which affect the nature of the CX bond, and then we have the nucleophilic substitution reactions of aryl halides, mechanism of the nucleophilic substitution reactions of aryl halides. Thank you so much.